That confidence score your LLM just returned, the one that says 97%, it doesn't mean what you think it means. It might not mean anything at all. You've been making decisions based on a number that was never designed to measure what you're using it for. And the worst part is, the model has no idea it's wrong. As developers, we trust data. We build systems around logged outputs. We write assertions. We add observability because we don't ship guesses. But somewhere along the way, we began treating LLM outputs like query results. A confidence score popped up, and our brains promptly filed it under reliable signal. That's not a character flaw. It's a very reasonable misread of a very misleading interface. Here's what actually happened. The AI industry bolted human-legible certainty language onto a system that produces probability distributions over tokens. The model doesn't know anything. It assigns likelihood weights. When it says the capital of France is Paris with 99% confidence, and the Treaty of Westphalia was signed in 1648 with 99% confidence, it's using the same mechanism. One is correct, the other might be off by a year. The score doesn't tell you which is which. In most transformer-based LLMs, there is no direct confidence output. What you get from the API, if you get anything at all, is a log prob, a log probability. It's the model's softmax output for the most likely next token. That's not the same as how correct is this answer. It's how strongly did the model commit to this word given everything before it. A model can be extremely committed to a wrong answer. It happens constantly. OpenAI's API returns log probs if you ask nicely. A score of negative 0.01 looks very confident. But log probs reflect fluency and pattern reinforcement, not factual accuracy. The model has seen millions of documents where the Battle of Hastings is followed by 1066. It's confident because that pattern is burned in, not because it checked. GPT-4 flagging a hallucinated legal citation with 98% confidence isn't a bug report. It's the model doing exactly what it was trained to do: produce fluent, coherent text. The confidence is in the token sequence. The accuracy of the underlying claim is a separate question the model isn't even asking. This distinction doesn't show up in the output. That's the problem. A well-calibrated model is one where 70% confidence claims are correct about 70% of the time. That's the standard. Turns out most LLMs are not well-calibrated, particularly outside their training distribution. Research from 2023 on GPT-4 and other frontier models showed systematic overconfidence in specific domains: law, medicine, niche historical events, exactly the domains where people are most likely to rely on the output. The overconfidence isn't random. It clusters in high-stakes domains because those domains are heavily represented in training data: legal briefs, medical abstracts, historical encyclopedias. The model has seen enough of that genre to write it fluently. Fluency reads as authority. Authority feels like accuracy. None of those are the same thing. So the model is most confidently wrong in the places you most need it to be right. That's not irony. It's a direct consequence of training on human-generated text where confident-sounding prose is disproportionately produced by experts who, in their domain, usually are right. The model learned the register, not the epistemics. You made it halfway. If the log prob thing was new information, stay with me, because what's coming next is the part that actually changes how you work. If this channel looks useful, subscribe now. I'll explain why the problem gets worse the more you trust the model, and then I'll give you the exact prompting patterns that reduce it. Here's a counterintuitive one. The more confident sounding and detailed the output, the more likely something in it is wrong. This isn't speculation. It follows from how these models generate text. Longer outputs require more token predictions, and each prediction is like an independent roll of the dice. Over a long, authoritative sounding response, the probability of error compounds. So ironically, the model that says possibly, though I'm not certain, is actually demonstrating genuine calibration. Certainly, the format of the output is doing persuasion work on you. Bullet points feel verified. Numbered steps feel procedural. Code blocks feel executable. None of that formatting emerged from a reliability check. It emerged because that's what confident-looking technical responses look like in the training data. Your visual parsing system is being used against you. Understanding this gives you the power to look beyond the formatting and question the content itself. A code block in an LLM response is particularly effective at bypassing skepticism. Code looks testable. It implies that someone could, in principle, run it. Developers are trained to trust runnable artifacts. The model knows, in a statistical sense, that code blocks signal precision. It has no idea if the code works. Neither do you, until you run it and something breaks at 2 a.m. The most common defensive move developers try is the confidence reprompt. You ask a model to rate its certainty, or you follow up with, "How confident are you in that?" The model obliges. It produces a confidence assessment. That assessment was generated by the same process that generated the original answer. It's not an independent audit. It is the model predicting what a confident-sounding self-assessment looks like. In practice, reprompting for confidence tends to increase stated confidence. The model pattern matches to "this person wants reassurance" and provides it. You have not added a verification layer. You've added a second opinion from the same unreliable source. The mistake has a certain elegance to it. You're using the tool to validate the tool. It's like asking a magic 8-ball if magic 8-balls are reliable. There is a version of confidence elicitation that works, but it requires restructuring the prompt, not re-asking the same question. The key insight is that you want the model's uncertainty to surface during generation, not be retrospectively assessed. Those are different tasks. One requires the model to hedge as it goes, the other asks it to evaluate itself after it's already committed to an answer. Sure, here's the narration delivered clearly and engagingly. First, explicit uncertainty elicitation. This pattern instructs the model to separate what it knows from what it's inferring. You prompt it like this: answer this question, then list any claims in your answer that you are less certain about and flag the ones where I should verify against an external source. This doesn't eliminate hallucinations. What it does is surface the model's own token-level hesitation in a way that's useful to you. Second, contrastive prompting. Ask for the answer and the strongest counterargument simultaneously. If the model can't generate a coherent counterargument, the claim is probably solid. If it can, you know exactly where to probe. Third, decomposition before generation. Break a factual query into subclaims before asking the model to synthesize. Ask each subclaim separately. Inconsistencies surface fast. One contradicting its sibling is a flag, not a deal breaker. So here's the payoff. The confidence score isn't lying to you. It never claimed to measure factual accuracy. You inferred that it did, because a number that high, attached to an answer that fluent in an interface that polished, carries the visual grammar of verified output. The model is a very good text predictor that learned to write like something that knows things. The confidence is real. It's just confidence in the token sequence, not in the claim. That distinction is the entire problem. Now you have it. One thing you can do today, add a system prompt that says if any claim in your response is based on recall rather than something explicitly provided in context, flag it with unverified. It won't catch everything, nothing will, but it shifts generation behavior toward hedging rather than projecting certainty. Try it on your next GPT-4 or Claude API call, and drop a comment. Has a high-confidence LLM output ever passed you actual time, a bug, a wrong implementation, a source that didn't exist? I want to know the domain. That'll tell us where the next video needs to go.